So at first glance, something like a tree seems really complicated. We can see here this is a nice little 3D asset scan, but we have this visual of these trees and it looks like they have so much going on. Obviously we can see the trunk and maybe you can get some idea of texturing and modeling how we can get it to look like this trunk. But all these leaves, now as you start to look at it closer, you might notice these leaves seem to be repeating pretty frequently. And when you start to see the pattern, you see it's the same clump of leaves over and over and over again. But how are some parts of the leaves see-through and some parts aren't? This is what we're going to be talking about today when we discuss opacity. You can see what they do is they turn into something we call a card, and we distribute that card on the surface of the model. This is often done for things like torn clothing or chains or other little furry kind of details that are too hard to model because it required too many verts or too many points, and it's relatively small. So fur, hair, trees are often all done using this, what we call a card method. And they sort of take this and they'll render out an image like this and use it to piece all the pieces together to create a final tree. So I'm going to show you how that works. So I'm inside of Blender here, and I'm going to create a new material for this, and this is going to be my alpha demo. And let's get my scene with all my little icons so you can see all my button presses. And I'm going to bring in an image that will help us kind of pick out this detail. So I got my alpha card and I'm going to plug something into this slot. So right here is alpha, and it's sort of how see-through this thing is. Now right now it doesn't do anything because it's not set up properly to be an alpha object. In our material settings down here, we can turn on these modes. So blend mode says, how much do I show the world through it? Let's set this to alpha. Clip means it chops it off. I'll show you what these different ones do, but let's do it as a alpha hashed, one of the most popular ones. And then I'll take this shadow mode to, the shadow mode is to, let's say this is alpha hashed as well. Hash is going to mean that it can smooth itself out, whereas clipped is always going to be sharp. So let me bring in a simple black and white image. I know everything went away, thanks Windows. So I have on my desktop here a little logo that I'm going to drag and drop into my scene. And instead of putting this into color, which I mean I could, this is a little owl guy right here. If I also plug this into what's called alpha channel, not the alpha into alpha, just the regular black and white, we can see in a second, it's going to take everything that's black and it's going to cut it out because that's what was there before. And so now I can just take the base color, and it can be anything I want, but it's always going to show, and make a duplicate, move it under it, it's always going to show the next layer through. So I can take this too a step further. Right now, we can see, again, that visualization here. Black means it's going to see through it. It's going to be clear. It's going to be transparent. White means it's going to be opaque. Means that's where the image is going to show up. And anything gray is going to be somewhere in between. So for instance, if I wanted to really play with this, I could run it through a ramp. So let's take a color ramp and I'll plug it right into the middle of this. And let's change this black color into something a little lighter, like a gray, something like this. And then we'll plug that into our alpha and see what happens. So now it's seeing through, but it's sort of partially seeing. We can see it's got this kind of interesting blending. This is alpha blend tends to work a little bit better for showing partially through. Let me put another object behind it just so we can tell a little bit better. I'm going to stick another plane back here. Let's create a new material for it, and I'm going to give it a nice red color. So we see that we can only see through these areas, and we can partially see through. It doesn't bring the whole color through. And depending on what I set this value to, from all the way to black to all the way to white, it's sort of blending out. Because we can do the same thing, of course, here with this alpha, sort of partially there to show it's sort of in this mix and sort of not. However, if we set it to something like alpha clip, it'll either be on or it's off. Clip means it's got just that one setting. It doesn't blend or blur or smooth out, which is sometimes what you want for things like glass materials or something like that. But this one just clips out. And clip is cheaper. And by cheaper, I mean it takes less processing power than something like hashed, which requires a lot more to test those things out. And so I usually, for stuff like grass, chains, even things like hair, sometimes you want to stick those with alpha clip because it takes less of the computer to say it's either transparent or it's not. Now, here's the thing about this. As soon as I turned this on and I made this set to alpha clip and alpha test, even though nothing's in alpha right now, and I could set my alpha to 100%, it's still shooting rays down through here, and it's trying to say, hey, shoot a ray down through here, bounce back up, what do I see? Shoot a ray through here, bounce back up, what do I see? Every time we use an alpha, and especially when we layer alphas over alphas, it has to do what's called an alpha test, which it has to say, is this transparent and is it opaque? Even if our alpha is set to 100% or 1. This is why we only use alpha if we absolutely have to. And when you're texturing things, if I'm doing a model that say is like a clock, and it has a wooden texture on it, but it also has like a glass face on the clock, I'm going to keep those as two separate materials because I don't want to do, otherwise it's going to take the whole clock with all of the wood and try to alpha test everywhere on it, even though I know it's not transparent. So we always split up those objects as much as we can. Get rid of my annotation again. So what we can do now, if I take this and I run this color into my alpha, and let's do this back to black, so that'll show through. Also, I can reverse these. So let's just get just the thing in here. So I can go here and flip color ramp, and it will invert that. So now you see I've got like this little geometric kind of looking thing, and this would be really difficult. Look at the complexity I would need to have in this model to get it to look exactly like this. Say I was going to try to have like lace or something like that in a program. However, everything around the owl, even this corner here, is all being tested as we say out. So often what's really smart to do with something like this is use your knife tool and you just sort of cut a nice outline. You don't have to be so precise, but the more extra space we can avoid having to test on, the better. So I'm just going to make a couple of these, sort of like tracing it. I don't have to be super precise, just the general idea. I just want to say everything going on top of this. Sort of tracing it like I would be in Photoshop or something like that. I'm right back to here. Enter 3, select the owl, Shift I or Control I to invert, delete everything else. And now I have, as a model, the same essential look, but what that means is right here, down in this corner, it doesn't have to do an alpha test here, which can really save me a lot. Because while it's not that much processor-wise for one owl, what if I had hundreds of these owls and I wanted to check through each of these? Every time an alpha has to pass through another alpha, it has to do another layer of testing. And so that can actually really increase in your complexity. So you want to avoid it unless you have to. And you want to keep that relatively simple if you're going to do something as complicated as, like in that example, like a big tree, because every time these have to go through each other, it has to test, and those can really add up. Although these days with good computer progress, good consoles and PCs, we can do a lot more. And in a lot of cases, things in a scene like this, the leaves on a tree are going to have way higher vert count and way more texture space than the trunk is. Just like on a character, hair on a character is more than half of all the verts and bones on a character, because the complexity of little things being able to move around by themselves. So alphas exist down here. We could plug them into just about any object and use them to help us block out details that would otherwise be way too complicated to model by itself. In the next video, I'll show you how to use these techniques to start generating some plants.